Hi everyone, today we will discuss about minimum spanning tree. Two algorithm is there, one is Prim's algorithm, one is Kruskal's algorithm. Okay, so first start with the definition of minimum spanning tree. A MST is a tree that connects all vertices in a graph with minimum total edge weight and without forming any cycle. Okay, this is the definition of MST. Connect all vertices in a graph with minimal total edge weight and without forming any cycle. So this is MST. So what is minimum spanning tree? So minimum spanning tree must have all vertices connected, minimum total weight, no cycle. These 3 points are important. Okay, in MST, all vertices should be connected, minimum total weight and no cycle in the graph. So what is cycle in a graph? So cycle is a path in a graph where a vertex is reached again after traveling through edges, right? Is simply called as the cycle occurs when we start from a node and return to the same node again. That is called cycle, right? So start from one node and return to the same node is called cycle. This is the example, A to B, B to C. So this is cycle, okay? Then here in MST using the greedy method to find the solution. What is greedy? In MST algorithm commonly use the greedy method. Greedy means choose the best option as the current step. Okay. In current step, what is the best answer? So we will choose that answer. So for the final result. So in MST, we repeatedly choose the minimum weightage without creating a cycle. So here MST uses the greedy method. What is greedy? Greedy means choose the best option at the current step. Okay, best option at the current step. Okay, so important points to remember: handle both positive and negative edges. Okay, in MST handle both positive and negative edges applied only on an undirected graph. Okay, in MST the given graph must be an undirected graph. Okay, no directions are present in the graph. So first we will start with the Prim's algorithm. So what is the algorithm? Start with any vertex, select minimum edge connected to MST, minimum spanning tree, add new vertex to the MST and repeat till all vertices are included, because we connected all the vertices, right? Then we form V minus 1 edges. So number of vertices is 6, means we need 5 edges to connect all the vertices. Clear? Okay, start with any vertex, but the best option is choose which one is the minimum cost. We start with that vertex. That is best way to find the MST in Prim's algorithm. To create the MST using the Prim's algorithm, here is one example is there. This is undirected graph. So here we start from any vertex, but best option to choose which vertex have the minimum cost. Okay, here which vertex have the minimum cost? 10, right? 10 is the minimum one. Oh, we start from 1 here. Now we start from 1. Okay, so now this is A, B, C, the step, because 1, 2, 3 as already is in the vertex name. Okay, don't be confused. This A, B, C is the steps one by one. Okay, the first step A denoted as A. So first we add this edge in the minimum spanning tree. So we choose any vertex, but which one is the best option? So which edge have minimum weight? Then choose that edge first. That vertex is connected in the MST first. Okay, so take this edge first, 1 to 6. So 10 is the minimum. So we add this edge in the MST initial. Then what is then find out the next minimum path, next minimum edge, but that edge connected with either 1 or 6, because already these two vertices present in the MST, right? 1, 6. So you find next minimum cost edge, but that edge start from this vertex, right? 1, 2 or 6, 2. So here we check it out. Next minimum edge is 12, right? 12, but 12 is not connected, either 12 is in separate edges. So 4, 2, 3 not connected with 1 and not connected with 6. Don't take this edge. Okay, so we find the edges connected with this either 6 or either 1, because these two vertices are already present in the MST. Clear? So what are the edges are there? So 6 to 5 the weight is 25. 1 to 2 the weight is 28. Which one is minimum? 25 is minimum, right? Then we connect 5 with 6. So we make this edge in this second step. Clear? How to choose this 5? So we check the minimum weight from minimum possible weight edges from 6 or 1. Here 2 edges are there. One is connected to from 6 to 5, another one is connected from 1 to 2. Alright. So we choose this because 25 is less than 28. So we choose this edge. Clear? Then again we check what are the edges are available from 1 or 6 or 5. So which one is minimum? We add that edge in the given MST. In this MST, right? Okay, check it out. 6 to already added 1 and 5. So no more edges are there. Then 1 to 2, 28 is there. 5 to 4, 22 is there, right? 5 to 4, that is 22. So which one is minimum? Compare with the 28. 22 is minimum weight, right? Then add this edge, 5 to 4. So add 4, vertex 4 to the MST. Clear? 4 to the MST. 22 is minimum, then add 4 to the MST. Then next we check the edges connected with 1 or 5 or 4 or 6. 6 have no edges. Then again 5 is already connected with 4. In 5 one more edges are there. We check that edge also. Okay. Then 1 to 2, 28, 5 to 7, 24, 4 to 3, that is 3. So which one is minimum? Based on these 3 wedges, which one is minimum? Now only, so these 3 possibilities are there, right? So 1 to 2, 5 to 7, 4 to 3. Which one is minimum? 12 is minimum, right? Then add vertex 3 with the vertex 3 in the tree. Okay, we connect vertex 3 in the tree. Clear? Then again check what are the possibilities are there now newly. Okay. Then 1 to 2, that is 28. 3 to 2, so already connected 3, right? So 1 to 2, 3 to 2. Then 5 to 7, right? 5 to 7. 5 to 7 is 24. So 3 more edges are there again. So 28, 24, 16. Right? Which one is minimum? 16 is minimum. So we connect this vertex. Vertex 2. We add vertex 2 in the tree. Right? So connected 2. This is the next step. So connected 2. Then we again check it out. What are the minimum weight are possible. So from 2, from 1, from 2 and from 5. Right? Just check it out. From 1, that is 28 again. Still not connected, right? So 28 is there. Then 5 to 7, that is 24 is there. Then 2 to 14, that is 2 to 7, that is 14 is there. 3 edges are there. But we add this, which one is minimum? 14 is minimum. So we simply take this. Okay, 2 to 7. So we add. Now we will add the vertex 7 in the tree. So vertex 7 in the given tree. Okay, likewise. Now all the vertices are connected in the tree. So the procedure is over. How many edges are there? V minus 1 edges. So the vertices is 1, 2, 3, 7 vertices are there. The edges is 7 minus 1, 6 edges are there. 1, 2, 3, 4, 5, 6. 6 edges is enough to form the MST. Clear? So one more important thing is we add. So during adding the vertices in the given graph, just check it out. That graph, that edges should not form the cycle. So that is one important thing. So if 3 vertices are there, as 1 to 2, 2 to 7, 5 to 7, these are there. Because here in sometimes 8 here is the minimum edge means we because here we assume that here now 7, the actual the weight is 7 means just assume that we don't choose this weight, don't connect 2 to 1 because this forms cycle, right? If choose this 7 means here we connect this the form cycle. We cannot do this. Okay, if the weight is minimum also we cannot add that connect, we cannot connect this to vertices because it forms cycle. That also an important thing, keep it in mind. Clear? Clear? So initially we start which one is the minimum weight, so that is add in the MST initially, then find the minimum edges from that is important thing, find the minimum edge from already available vertices in the MST. So here already available vertices 1 and 6, we find the path from 1 or 6 which one is minimum, add in the MST. Find further we add the form the MST. Likewise we will still included all the vertices in the given graph. We repeat the step again so again and again. So don't form the cycle if the particular edge is minimum but that edge form the cycle means don't add that edge in the MST. Okay, clear? So the what is the total cost? Simply add all the cost in the MST. Okay, and this is called cost or weight. Okay, the total cost is 99. This is the procedure of Prim's algorithm. Clear? Thank you.